In this lesson, we will go over some basic definitions for polynomials and also to classify polynomials. So first of all, I want to talk about what is a term. Well, a term is a number or a product of a number and a variable that could be raised to a power. In other words, it could be a number and variables raised to some power multiplied together. Such as in the first term here, you have 4 and then you have x cubed. Any of that is called term when you have a number and variables, whether they're by themselves or whether the number and variable is multiplied together. When they're separated by plus or minus, then they are called terms. So here we have 3 terms, and 3 terms, we'll talk about a special name for them, but they are polynomials. Okay, so let's classify polynomials. So we start with a monomial. Mono, the prefix, means 1. So whenever you just have one term, it's called a monomial. Binomial, prefix bi, means 2. So whenever you have an expression containing 2 terms, it's called a binomial. Trinomial, prefix tri, means 3. Any expression containing 3 terms is called a trinomial. And polynomial, the prefix poly, means many. So anytime you have more than 3, you can just simply call it polynomial. However, they're all polynomials. They all fall under the umbrella of being a polynomial. This is just so you know what I'm talking about whenever I mention a monomial, binomial, or trinomial. You know I'm speaking of expression that contains whatever that number is. In the case of mono, the 1, binomial 2, trinomial 3, polynomial, you may have several terms there. Our next objective, we want to talk about the degree of a polynomial. Identifying the degree of a monomial. So we talked about a coefficient. Recall that a coefficient is a number factor in a term. The degree is when you add up all the variables in a terms. So again, it is the variables. It has nothing to do with the number. The degree has only to do with the variables. So what you do is you look at the degree or what the variable is raised to and add them all up, and that will be your degree. So let's take a look at some degrees here of terms. So here we have negative 6y raised to the 4th power. So obviously, yes, the coefficient is negative 6, but in terms of the degree, we look at the variable. We only have one variable. Its exponent is the degree, and that's 4, so the degree of that term is 4. Looking at the next term here, we have x raised to the 6th power over 1/9. Recall the coefficient there was 1/9. So the degree is the variable. We only have one variable, and that's x. It is raised to the 6th power, so therefore the degree of that term is 6. For the next example, we have our variables. We don't have we have a coefficient of 1, that term, but we want to focus on the variable because the degree has to do with only the variables. So x has a degree of 1. Y has a degree of 4. So when you want to find the degree of the whole term, it is the sum of all the exponents. It is the sum of the exponents of all the variables. So I have to add all that up. So that's 1 plus 4, which means that this term has a degree of 5. Next, Here, obviously, yes, the coefficient is 2.5. Now we want to know the degree. Let's look at our variables. They each have a degree of 1. If we add them all up, that term has a degree of 3. Here, on a negative 11, we want to know what the degree is. Degree has to do with variables only. There are no variables, so therefore the degree is 0. Now let's talk about the degree of a polynomial. That's different. Now, to find the degree of a polynomial, it is the greatest degree of the monomials from the polynomial. Now, remember we talked about monomials, one term, and all of these terms are separated by a plus or minus sign in there. For example, in this polynomial, or the first example, it has 1, 2, 3, 4, 5 monomials. Now, out of all those monomials, I want to know which monomial has the highest degree, because that will be the degree of my polynomial. So, the first term does not have a degree. Second term has a degree of 4, degree of 1, the degree of 3, degree of 0. So out of all these terms or binomials, the one that has the highest degree is 4, the degree of 4. And that is the degree of your polynomial. Okay? Let's find out what is the degree of the polynomial. For this second example, we need to look at all the degrees. So let's go. The first term has a degree of 6. What is the degree of the second term? Remember, to find the degree of a monomial, you have to add up all the exponents that are involved. So that's 5 plus 3. That means this monomial has a degree of 8. So that means this one will have a degree of 4. The next one would have a degree of 2. The last one does not have a degree. So out of all these terms or all these monomials, the highest degree is 8. Let's take a look at the last example. The first one has a degree of 5. The second one, 6 plus 1 is 7. So the second monomial has a degree of 7, then 6, then 1, then 0. So out of all these monomials, the one that has the highest degree and that degree of that highest one would be 7. And that is how you find the degree of a polynomial. In this example, I want you to identify each polynomial as a monomial, a binomial, a trinomial, or none of these. Now we know they're all polynomials. They fall under the umbrella of a polynomial, but I want to get you to give its other name that it's known for if it has one. So if not, you say none of these. Also, I want you to determine what the degree is. So let's start with the first example. Would you say that this is a monomial, binomial, trinomial, or none of these? And when we say none of these, it's just you're saying that it doesn't fit any of the 3 categories, and so then we would just call it a polynomial. So what would you say? Well, I see 2 binomials with a plus sign between them, so that's 2 terms here. 2 bi prefix, so that is a binomial. What is the degree of this binomial or We can even call it a polynomials. And again, you would look at both monomials and then whichever one has the highest. So we see here that it would be 5. So the degree here is 5. How about the next example? 20x to the 6th power, y to the 3rd power, z. They're all bunched together. There's no plus or minus sign that is adding on another term or subtracting another term. So it's just 1. And what do we call one that has 1? You got it. It is a monomial. And what is the degree of that monomial? So recall, to find that, you're going to have to add up all the variables of the exponents, and that will give you a degree of 10. Let's do 2 more. So what would you say this polynomial would be classified as? Well, I see 3 terms or 3 monomials. So therefore 3 tri, it is a trinomial. Now let's find the degree of this trinomial. So out of the 3, which one has the highest degree? That is correct. It's 6. If you said 6, then you are correct. Let's take a look at the last example. That one has several terms in it. So we would just simply call that a polynomial for many terms that are there. So what is the degree of this polynomial? So make sure you look at all the monomials and see which one has the highest degree. If you said 7, then that is correct. And there you have it, classifying polynomials and knowing their degrees. Our next objective is to write polynomials in descending powers. Polynomials are usually written in standard form, in which the terms are arranged in descending order from the largest exponent to the smallest exponent. So that is the most common way to write a polynomial. So if you take a look at the polynomial here on the screen, notice that the degrees the exponents are not in order for the highest degree down to the lowest degree. So we need to get this in order. So to put this in order, the first term, or what we call in math the leading term, should be the 7x to the 4th power, because that is the highest degree. So it's degree of 4. Then you should have degree of 3 next. So behind that should be the term negative 2x cubed. Then your term plus 9x squared, because we're going 4, 3, 2. Now I need the degree of 1, which will be plus 3x. And your constant, your number by itself, or your integer, should always be last when you're writing the numbers in descending order. And there you have it. Now the polynomial is written in its correct standard form.